Hello guys, welcome back to my video series on the Black-Scholes option pricing model derivation. In this video, we're going to be talking about the payoff function for option contracts. In the past two videos, we defined what an option contract is, what it consists of, and also some real-world examples of how it may play out. In this specific video, I want to discuss the payoff ratio of these option contracts. So let's start with the call case. Same way we have calls and we have puts. And I want to start with the buyer of the call. And in this case, I want to say my strike price K is at $100, and I want to think about two cases. I want to think about my premium V1 as $2 and my premium V2 as $1. And I can construct a payoff function as follows. And let's start with the V1 case where my premium is $2. So my strike price is going to stay at $100 in both cases. So let's note that down as $100. And my first case is at $2. So let's say this is my $2 mark. So for the buyer's side, on the worst case, his option expires worthless, so he will lose $200. It's going to be negative 200. And this happens up until the point where the stock price meets the strike price. So this axis is going to be my stock price as a function of time. This is my stock price. Now, after that, I'm going to have a linear growth until I have a break-even point. And then after that, with the same linear growth, my payoff is just going to keep increasing. Now, using the last example, if I were to profit, or if my stock price were to end up at 102, then I would profit $2 per share. And since every contract is 100 shares, I would profit $200, which would break even with the premium that I paid. So this break even point is going to be $102. And anything after $102, I would make profit as a buyer. Now, in the other case, where I'm thinking about V2, I would initially be down $100, obviously going up to the strike price. And then after that, I would also have a linear growth until I meet $101. This is because if I profit of $1 per share, then $1 times 100 would be $100, which would completely break even with the premium that I have paid. Now, in the same way, I can do this payoff ratio for the seller of my call. Now for my seller, with my first case, he would start with a profit of $200 up until the strike price of K, which is $100. So he would profit this until he gets to $100. Now, until he gets to 102, he would continue making profits even though they would diminish. And once the stock price S crosses 102, the seller would start seeing diminishing returns. And in the same way, if my stock price was, or my premium was at $100, I would see profits as the seller of this contract until $100, until my stock price hits $101, until I see diminishing returns. Cool. So now that we talked about calls, I want to talk about the same case for puts, which I'll do down here. And I'll use the same exact strike price and the same exact premium to be paid. So for the buyer, this is going to be the buyer. It's going to be my stock price, and this is going to be my strike of $100. So this is going to be the reverse, right? So essentially, as a buyer of a put, I want my stock to stay under the strike price, as opposed to a call where I want my stock to stay above the strike price at the final time t. So with this case, once I reach, for example, $100, then I would be losing $200 as the buyer. And obviously, when it goes down to $98, my stock goes down to $98, I would break even. And then I would go up until my stock were to reach 0, and this would be my maximum profit. Cool. And we can do the same exact scenario for my second premium to be paid, which is $100. In this case, I would see negative returns until the strike price of 100, and then once I reach $99, I would start seeing profits. And I actually have a greater maximum return in this case. Now, the seller of this contract would also have a payoff ratio. I could draw that out as such. This is my stock price, the y-axis is my payoff, and then I have a strike price of $100. So at $200, if my stock price is greater than 100, I would see my maximum profits of 200. And obviously, if this were to go down to $98, I would break even as a seller. And I have a maximum loss in the same way the buyer has a maximum profit. Cool. And then I could also do the same case for $100, where my premium to be paid is $1 per share. And in this case, I would break even at $99. My maximum payoff will only be $100. And my maximum profit would be a lot lower than if my premium were higher. So just to zoom out a little bit, these are essentially going to be the four cases for calls and puts for both buyers and sellers. So there's one very important thing to notice over here. In the buyer's case, he wants the premium V to be as low as possible. Whereas the seller wants the premium to be as high as possible. So essentially what happens with option contracts is there's almost a tug of war between the buyers and the sellers. The seller wants, again, the price of the premium to be as high as possible, whereas the buyer wants the premium to be as low as possible. And this is because of how the payoff ratios work out. So the question is, what is the fair price to pay as a buyer or a seller? And this is the question that's going to be solved using the Black-Scholes model.